Hello, welcome to Sick Notes. My name's Ed Hope. I'm a junior doctor in the UK, and on this channel we take a look at everything to do with medicine, the human body, and what it's like to be a doctor as well. I know it's been a long time coming, I'm really sorry, but I'm continuing my look at the fantastic series Cells at Work. So this is episode 8, Blood Circulation. Okay, so we have red blood cell in the house, or more accurately in the inferior vena cava. Inferior means beneath as opposed to superior, which means above. So the inferior vena cava is the main vein that collects all the blood from the abdomen, the pelvis and the lower limbs and returns it to the heart. Whereas the superior vena cava would collect all the blood from the head, the neck and the upper limbs, and again would return it to the heart. Don't forget, the blood travelling in the veins has already supplied oxygen to the tissue, so we call it deoxygenated. This blood is a slightly darker red colour, as we can see here, as a red blood cell has the dark side of her jacket showing. Also, the red blood cells in venous blood are slightly larger too. This is because red blood cells have a key role in transporting carbon dioxide. To do this, chemical reactions take place within the red blood cells, and this draws in water from the blood plasma, making the red blood cells slightly bigger. Cool, so the red blood cell is lost again. This is a lovely overview of the circulation system of the body. So we see the arteries supplying blood to the organs from the heart, and the slightly darker red colour of the blood in the venous system, taking it back to the heart. Frequently we see veins in diagrams like this depicted as blue. They aren't blue, they're red, as we said earlier. It's just the skin and soft tissues over the top of the blood vessels make them look like they're blue. A couple of nice points worth pointing out here. First of all, we see the liver here, a major metabolic organ. It creates important proteins, breaks down toxins, stores vitamins and sugars, and also produces digestive juices, so rightly has a large blood supply. And the outline of the stomach here, probably representing the whole of the gut actually, again a very active organ, and we get preferential blood supply when we've had a meal, so it can not only get more energy to work but also give an opportunity for all the nutrients from the food to get into the blood supply. And notice here how the blood from the gut doesn't go straight back into the venous system. Important, but a nice little touch. This little vein connecting the gut to the liver is representing the portal system. Sounds like some kind of time traveling apparatus, when in fact it means that everything from the gut is first passed through the liver, which makes complete sense, right? It gives the liver an opportunity to process all the proteins and break down some of the toxins before it gets released into the systemic circulation. Although I know if I don't mention this, I'll get so many comments. There are blood vessels that go directly from the gut to the systemic circulation. We call these portosystemic anastomosis. Porto because this is called the portal system, systemic because it's going to the systemic circulation, and anastomosis is a term we use when two tubes are connected together, in this instance blood vessels. And last but not least, down the bottom here we have the kidneys. Again, a super important organ, has lots of functions actually, but primarily involved in regulation of the blood and in turn regulation of the body. So passing water, getting rid of waste products and maintaining your blood's pH. Again, a significant amount of blood flow is required to do this. So the kidneys would be receiving around about a quarter of your heart's output. Who the hell is this guy? We find out that they're a germ, so a general term for a bacteria, virus or fungus. I'm not sure what specific germ this is. There's normally clues to hint at what it is, but I'm not too sure. But many of them can cause hemolysis, as perfectly described here. It means destruction of the red blood cells. So heme referring to hemoglobin in the red blood cells, and lysis meaning to split open. We've met lots of bacteria in previous episodes that cause hemolysis, including Streptococcus pneumoniae, Streptococcus pyogenes and Staphylococcus aureus. And whatever germ it was, it's gonna last long because, you know, white blood cells back in town. Cool. So we know red blood cells don't have a nucleus. We learnt this in episode 6. This is so there's more room in them to carry hemoglobin. And for a similar reason, they don't have mitochondria. You can't say that word without saying it's the powerhouse of the cell. So if red blood cells don't have their powerhouse, how do they perform respiration in order to get energy to maintain their cell membranes and perform chemical reactions? The truth is that mitochondria are not the only way we produce energy. They are by far the most efficient way of producing energy via a process that involves the Krebs cycle, but another process can take place in the cytoplasm of the cell, a process called glycolysis. We learnt the term lysis earlier. So this is breaking down glucose into pyruvate. This is not a very efficient way of generating energy, but it's also the only way of creating energy without oxygen, so-called anaerobic respiration. So without any mitochondria, the red blood cell would be creating small amounts of energy through glycolysis within its cytoplasm. So we meet the heart, and I like the way they've done it in this kind of public information video, like the type of thing you'd get at an airport. And it's funny, they use the term congested here. Using congested in the context of the heart is not a good thing. So when the heart begins to fail, we get blood backing up in the veins. This is what we refer to as congested. And the whole process itself we refer to as congestive heart failure. I don't think that's what they're representing here. They're just explaining that lots of blood is returning to the heart. There's this amazing overview of the circulation in this segment, showing the blood flow from the right side of the heart to the lungs, to the left side of the heart, and then to the whole body. People learning circulation system should definitely check this out. I definitely recommend it. I know they allow stuff to be shown in school, so this thing in particular would be very good to teach from. So let's follow the path ourselves using their diagram. So our heart is a beautiful muscular pump made up of a right side and a left side separated by a central septum. Each side has two chambers, the smaller atria at the top, whose job is to fill the larger ventricles beneath it, whose job it is in turn to send blood to the lungs if it's the right ventricle, or to the body if it's the left ventricle. And to make sure that this blood flows in the correct way, there are 4 valves on the exit of each of these chambers. Cool. So first stop, right atrium, and they're waiting to go through the tricuspid valve into the right ventricle. So as beautifully explained here, the tricuspid valve allows blood to flow from the right atria to the right ventricle, but stops it flowing back through the other way. Tricuspid, as they say here, tri meaning 3, and cuspid because we call the flaps of the valve, the leaves of the valves, we call them cusps. So this valve has 3 cusps. Oh my god, this is so cool. So we're in the right ventricle now, and these string or cords from the ceiling are instantly recognizable as the chorda tendineae, literally meaning tendon cords. And if you cut open a ventricle, this is exactly what you'll see. These cords are attached to the cusps of the tricuspid valve and stop the valve from effectively turning inside out, which would obviously compromise the valve. If the valve's compromised in any way like this can happen pathologically, we'd call it the valve insufficient or regurgitant. So this is when a valve is open when we really want it to be closed. The other problem with a valve is when it might be really difficult to open. So we want it to open, but it's not quite open. So this is, you hear it, patients refer to this as a sticky valve, but the medical term for this is stenosis. Any valve can become insufficient or stenosed, and this can lead to turbulent flow through the heart and therefore a heart murmur. That's all a heart murmur is really. So it's any turbulent flow through the heart, of which valve problems is one of the more common causes. Okay, so we're moving through the right ventricle, through the pulmonary valve and into the pulmonary artery, the only artery with deoxygenated blood. Pretty sure that's a regular pub quiz question. Cool, so we've reached the lungs and we see the alveolar sacs. This is the very end part of your airways. And so you have your windpipe, your trachea that divides into the two main bronchi, which divide into lobar bronchi. So your lung is divided into lobes, and then we have segmental bronchi because your lobes are divided into segments, and then we have subsegmental bronchi. So all of these are getting smaller and smaller, like this kind of tree-like structure. Then these further divide into bronchioles, of which there are many different types, which I can't remember off the top of my head, and then into the alveolar ducts, which is where we find the alveolar or the alveolar sacs right at the end. And these have blood vessels around them, as we can see here, because this is where the gas exchange occurs. So the main reason we have all these airways dividing up is to increase the surface area so that more gas exchange can occur. So here we see the red blood cell collecting oxygen as part of the gas exchange. So now it'll be off to the left side of the heart via the pulmonary vein, the only vein to have oxygenated blood. Another pub quiz question for you. There are two kind of gargoyle statues here. I'm thinking they're important because they're given quite a bit of prominence actually, but I can't think what they could be. So if you guys know what this is a reference to, then let me know below. I'd be interested to know. So we don't see the next steps, but from the lungs we go into the left atrium and then through the mitral valve into the left ventricle. Again, we'd see the chorda tendineae, this time belonging to the mitral valve. This valve has two cusps rather than the tricuspid's three. Then finally, the blood will be pumped through the aortic valve into the aorta and around the body, as we've just seen here. So I recognize these guys from the previous episode, Streptococcus pyogenes. As we mentioned earlier, they are capable of causing hemolysis. They produce a toxin called streptolysin that breaks down the red blood cell. But that's not happening today. Cool, and here we see red blood cells squeezing through a capillary, the smallest blood vessel in the body, and this is exactly what happens. By having them just wider than a red blood cell, it means that the oxygen and the nutrients in the blood can more easily diffuse through into the tissues. So there you go, my thoughts on episode 8 of Cells at Work. Not so much a story, this one, because it's not really about the kind of cells, more of the wider physiology of kind of how the heart works, which I thought they did a brilliant job in terms of translating. And this should definitely be used as an education tool. And I know they allow their videos and resources to be used in schools as well, which, you know, if I was a teacher in school, I'd definitely be using this stuff. They make it so accessible and they teach it in actually really good detail. So as always, if I missed any of the little details, then please let me know in the comments below. I love hearing from you guys of little theories and stuff I've missed and things like that. So if you enjoyed this video, give it a like and maybe consider subscribing to the channel if you haven't already. And to everyone that has and viewed this video and all the previous videos as well, as always, I can't do it without you, with your support, and I really appreciate it. So thank you so much, and I'll see you again soon.